So as and when a child gets proficiency in different subjects, the child is slowly promoted to the next class in that particular subject. So there is a lot of room for student teachers. When a child is lagging behind, and another child who has mastered that level of maths or English or science or whatever, that child can teach the other child. And it's a one-to-one mentorship. Both the children benefit, because you must have seen that when a person becomes a teacher, the person becomes a better student. And when a child is being mentored by someone who is little senior to the child, then the child feels more comfortable. And in return of this mentorship, we used to give them honorarium and we used to pay them. So slowly that culture started, earn while you learn, get the plastic bags, and we recycle those plastic bags, made bricks out of it. Like in a plastic bottle, we had so many kiosks and eating joints, etc. around. So from those shops also we used to get plastic and the plastic bottles. When you stuff the plastic bottle with plastic bags, then that bottle becomes a brick. Because as you know, plastic polythene bags have huge volume. But in terms of, huge volume when they are spread out. But they can be folded and made into very compact units. So that is how we made eco bricks with the help of plastic waste. And the eco bricks were utilized to make small structures in the school campus, as well as making the pathway going from one class to the other class. Because perhaps if you have seen our school, or if you have not seen, please look up aksharfoundation.org. We have several classrooms made of bamboo and hay and soil. So basically our school is also an eco project, eco entrepreneurship project, because I forgot to mention, but initially when parents did not want the school to be started there, we told them that why don't you come and work and help us build the school. And if we had to take them, we needed structure in which they were experts. So we started with local raw material, so which we could source from their own small garden, or from the hills they could cut the bamboos and bring, and they worked as laborers. So the school structures, we have several of them. In some language, in some form, one can call them huts also, but we like to call them school structures. So our school structures are also ecologically built. They are very reasonably priced, and whatever expenditure we made, that expenditure was spent for either giving wages to the persons who worked, or sourcing the raw material, which also we sourced from the community itself. So the beginning itself was in support of ecology, and now we have reached a level where the entire community has stopped burning plastic. There are many other areas in which we have progressed, but since the time is limited, I would not like to dwell on it. But what I want to convey is that our children have got a path whereby they can make a career by recycling the plastic. Different commodities they will learn to make. We have recently got some machines, so they can make different granules and different commodities from the plastic, as well as they have learned how to garden, how to do the gardening. They have acquired skills in gardening, sustaining the nature, sustaining the ecology. So this is one way in which our students' fortune is secured. This is one way in which they will also graduate from the regular regular boards, school boards. They will get matriculation degree, and at the same time, they will be in a position to stand on their own legs, earn livelihood while protecting ecology. This is just one experiment. There are several experiments going on in different parts of the country. Many people are trying it. And I think if we have the passion, we can certainly make things work. I suppose half an hour was allotted to me, but it would be better if we have more interactive session. So in the end, I would like to talk about one small poem by Rabindranath Tagore. The poem is like this. I'm telling you in the simple language, that when the sun was setting, the sun, sun, the sun was worried that if tomorrow I don't come to the earth, who will give light to the earth? So the sun approached the clouds and said that, oh, clouds, you create darkness in the day. Will you give some light on the earth when I'm not there? Cloud said, I cannot do that. The sun approached the mountains, says that, oh, you are so tall. You can create obstacles in the light. Will you give some light when I am not there? The mountain said, I cannot do that. Then the sun went to the sea, said that, oh, sea, you, I always sat in your bosom. Will you give some light when I am not there? Sea said, I cannot do it. The sun approached trees, uh, birds, and different entities. At that time, one small earthen lamp said that, sun, don't worry. If you don't come tomorrow, I will give light to the earth. I will enlighten this area. So, friends, what I want to tell you is that we may not be able to enlighten the whole universe, but like a small earthen lamp, we can bring light in the area in which we are situated, in our institution, in our home, in our suburb, in our village, small area. And if we can enlighten, if we can fill the whole small area with light, and if thousands of such other lamps are lit, then darkness will vanish from the earth. This is, in nutshell, what I have to say. There are many examples which I can give. So if there are some questions if you would like to ask me, then we can have an interactive session. Let us hear what the other speaker has to say, and then we will have an interactive session. Thank you very much, and I find the message.
Thank you so much, ma'am. It has surely given us tremendous insights into it. We'll surely take up the question answer round, but before that, I would request Dr. A.S. Sarpal sir to now address our audience. Over to you, sir.
Aman, you may have to help me. Anyway, I'm clicking on the present now. Okay.
Yes, sir. Yes, sir.
Now your entire screen. Okay, fine. Huh?
Sir, are you presenting the screen?
Yes. Yes, it is coming now. Huh?
Okay, sir.
Just because it's a serious problem, but anyway, it has come. I think. Huh? Just hold on, please. Just wait. Okay, is it okay? I think it is coming. Hello? Hello?
Sir, we can't see your screen.
Just let me.
Screen को चली गई.
See, I have just clicked on the present. That is.
शेयर करना.
शेयर करते हैं.
हाँ, शेयर आ रहा है कि शेयर करो स्क्रीन. शेयर करो. ਇੱਥੇ शेयर करो. हाँ, शेयर करो.
Aman, hello.
Yes, sir. Yes, sir.
I'm on sharing. It is not this. Icon is not on.
Excuse me, sir. So what is the color of the share button?
It is gray.
Sir, could you please click on the square box above it so it will turn orange?
Share box.
कैंसिल करो पहले फिर शेयर करो.
Should I cancel it first?
Yes, sir. You can try it again.
Cancel. Okay, let me try again. Entire screen. Okay, that is.
शेयर करो शेयर. तुम शेयर करो.
It's again gray. It's,
Sir, above it there will be a screen. Please click on the screen. It will turn orange.
which one screen?
Sir, just give us a minute. We'll present the screen in a while. You can
Just
give us a minute.
पापा की ना
it's share. It is gray. It is already Aman.
ये देखो जरा. मीनू दसती है की करना है. मीनू देख इसमें क्या करना है.
एक मिनट सीधा रखो, दिख नहीं रहा. ऊपर क्या हाँ थोड़ा थोड़ा लेफ्ट करो. हाँ बस ये शेयर योर एंटायर स्क्रीन. नीचे क्या बटन लिखे हैं दो.
नीचे तो वो जो
मम्मी विंडो पे क्या दो बटन बने हुए हैं वो बताओ. विंडो जो खुली हुई है शेयर योर एंटायर स्क्रीन के नीचे दो बटन बने हुए हैं मम्मी.
कौन से बटन है बताओ ना.
Aman, do you have a presentation of sir?
Aman.
No, ma'am, we don't have.
Yes,
Okay,
So they will-
Yes, ma'am. We have.
share.
Yes,
It is
yeah,
there now.
it is there.
Okay. It is there now. Okay, fine. Share the screen.
निकाल दो ना तो शेयर के. हाँ
ये मम्मी सामने
आ गया.
ये जो विंडो खुली है उसके नीचे दो बटन बने हुए हैं मम्मी. विंडो पे व्हाइट विंडो पे दो बटन बने हुए हैं नीचे. सबमिट के क्या लिखा हुआ है बताओ मुझे.
मुझे
आ गया. आ चुकी है.
क्योंकि पापा कह रहे हैं आ चुकी है. मैं
एक मिनट होल्ड करने
समझ आ रही मैं क्या बताऊं.
एक मिनट यार जस्ट.
पापा को सोचो.
आप थोड़ा सा पास कर दोगे स्क्रीन. कम से कम लैपटॉप के पास ही कर दो. मैं बोली जा रही हूँ मुझे विंडो दिखा दो. विंडो दिखा दो.
विंडो पे ही है.
ये
Aman.
पापा ये
एक
Yes, sir.
Aman, do you see the screen now?
Yes, sir, we can see the
एक
screen.
मिनट. Let me on a full screen. It is.
sir, your screen is visible and you can just
आ गया. एक मिनट.
मम्मी पापा को करने दो अपने आप.
हाँ ठीक है. आ गया. No, it is okay. Aman.
Yes, sir.
अच्छा. Okay, let you know. Let me present. Okay. Yeah. Okay. It's okay.
Yes,
I
sir.
think.
It's okay.
Afternoon, all my dear audience, respected faculty, and all the listeners. The topic is always, it is very hard. How to sequester means mitigate carbon dioxide. And carbon dioxide is because of all the human activities, burning of fuel, deforestations, and all that. Okay. And microalgae, I think, one of the agent. It is one of the most strong agent which can sequester carbon dioxide. It is a living organism, which I'm going to describe in the next slide. No, we are concerned with carbon dioxide. The recent NOAA report, April 2021, says the carbon level has already reached 412 from the pre-industrial time of 280 parts per million before 200 years back. And this level is today is before are, for example, synonymous. It is very useful for the production of, or you can say all the creams which you use on your face also, they can be produced by the cultivation of certain species. Then pharmaceuticals. I read one of the articles. There is one very strong company in the United States. They have taken up the task of synthesizing even paracetamols, all the you can say the essentials medicines which are used for the protection of different diseases, they can be produced by the cultivation of by the species. Carotenoids, all these are antioxidants, vitamin A and other things also. And at the same time, the solutions of microalgae, that is suspension, it is a good material for the production of silver, gold, zinc, and copper nanomaterial, which have an extensive application in the industries. As I already told, all the vitamins can be synthesized, can be found in the biomass, which is produced after the photosynthetic reactions. Now, it is very easy that you can grow microalgae in the ponds. It is called raceway ponds, or it is called an open ponds. But you can create also similar type of situation, which is called photobioreactors. You can use the sunlight. This is a photobioreactor. You have a vertical panels. These are normally the polyethylene or polypropylene tubes where the water is filled and microculture is added. So you can even grow microalgae. And this type of photobioreactor is used for only, you can say, for eating purposes, the food. That is a biomass, which is a source of protein. So normally the freshwater microalgae, it is used only for the production of, you can say, the food articles and others. Then you have raceway ponds and the different open ponds also. So so many types of, lot of research is going on, and our main the tendency of the researchers are how we can get a better photosynthetic efficiency, because you have to utilize sun energy so that you can at least have a better yield of the products. So photobioreactors are considered as one of the best, because here you have a highest photo efficiency, and at the same time it absorbs more carbon dioxide, so mitigate more carbon dioxide from the atmospheres. Now let us compare the crops plant versus algal oil productions. Crops at the most, they give you can say the minimum per hectare, gallons per hectare. You see corn, soya, mustard, and sunflower, they have maximum is the palm oil. It is the yield of gallons per hectare. But look at the microalgae. You can have how many times? Maybe 12 times, 15 times. That is the yield in the same area of cultivation. So that is why microalgae, it is considered as the future gold. You can say the future material for to be used as. Now, again, next comes the challenge. Now, it is very not easy to extract oils and other materials. As I told, a lot of applications. So normally we can use the extraction processes, and all the solvents, hexane, chloroform, methanol, ethanol, and ether, they are used for the extraction of certain components. Oil and fats is only we can use for hexane only. Oil and fats, hexane, chloroform, again for the oil and fats, and methanol for the vitamins and others. Now there are three processes. Bead beating, you might have heard in the milling. You press the solid mass in the bead beating, and milling, you get an oil. You have a Soxhlet process, and you have a supercritical fluid, carbon dioxide, which have been proved as one of the best solvent for the extraction of materials from the biomass. So what do? Take a biomass. This is an oil extracted. From this, you get an oil. You can produce biodiesel. You can produce gasoline. That is a petrol. You can aircraft fuel. You can produce the jet fuel. Jet fuel as you can say used in the aircraft, and you can use as a methanol. Methanol can be further use the pyrolysis and converted into fuels. Now, after the extraction, you get the residue. Residue is also very useful materials. It can be used as animal feed, proteins, fertilizer and can be after pyrolysis in the absence of oxygen. If you do the pyrolysis, you get a hydrogen gas. So how many material you can produce from the biogas? Besides, you can say the mitigation of carbon dioxides. Now, let's come to how you can produce a biodiesel. Let me show you first slide. What is biodiesel? You know, biodiesel, it is, you can't, it's by nature way. It has entirely different composition from the diesel which you get in the market, which is from the, you can say, our conventional sources. It is only produced from the vegetable and algal oil. What are the vegetable oil? You know, biodiesel is produced from the corn, from the soya, sunflower, and rice bran, depending upon the production in a different country. And in our country, you know, we produce biodiesel from the plant Jatropha plant, which has a glyceride. So oil and fats, they are converted into biodiesel. This is a biodiesel, which is nothing but it is called that is a methyl esters of fatty acids. So with the help of a catalyst, you get a biodiesel, and at the same time, you get a lot of glycerines. And glycerine is a very useful material for the different cosmetics, different industry. Even this can be converted into a lot of products. That is. So these are the main reactions. Now, let's come to how the microalgae convert carbon dioxide into gas. So you have a biomass. You get a carbon dioxide from the atmosphere, from the industry, even directly you can have from the industry, and you get a biomass. That is a lot of oxygens. And this is the glyceride structures. I think most of the students of chemistry, physics, and biology, they are aware of what is these are the triglycerides only. This is a triglycerides. So you do the transesterification, you get a oil, and directly you send this biofuels, which is called a biofuel, to the petrol pump for to be used for the transportation fuels in the trucks, even you can say in the cars. I mean, it's. Now, let us come to what is the fat matrix. The fat, that is a little bit chemistry, the fat matrix. They contain fatty acids, algal biomass, triglycerides. They contain, beside, this is a useful material for the biodiesel production, they also contains the epoxy acids, very good materials used for the paint purposes and the medicines. And also they contain phospholipids, very useful for our bodybuilding also, and at the same time, it is a rich source of phosphorus, which is required for our, you can say, making the bones stronger. So naturally, actually, you know, we are aware of what are fatty acids. You are aware of palmitic acid. You are aware of oleic acids. You are aware of lauric acid. You are aware of the unsaturated fatty acid, oleic acid. At the same time, these are the important fatty acids. E25, EPA, DHA, which are very useful for our, you can say, control of certain diseases in our body. And particularly these are the heart diseases. You might have heard fish is a source of PUFA, polyunsaturated fatty acids. Similarly, algae, you can say the microalgae is a source of PUFA, polyunsaturated fatty acids. And these are all, you know, the composition of microalgal oil. And at the same time, all the vegetable oils, it is a similar. The only difference is that our vegetable oil does not contain DHA, these types of PUFA, which are the essential fatty acid which is required for the human consumption. This is otherwise it contains the similar composition of the vegetable oils and corn, soybean, etc. That is why this is a good source of, you can say, material food supplements, vegetable oil. And another, I did some work. What is the difference between the mother milk and at the same time, what is the, you can say, the composition of the algal oil? The mother milk and algal oil, they have the same compositions because algal oil is produced by the microorganism and the mother milk is produced in the mother body. to lactation processes. So it contains mother milk, and at the same time, algal oil and fats have the same composition. That is why this nowadays, this algal oil is being supplementally into the baby foods and other materials. So how important is that? I think you have come to know the importance of using microalgae for the vast number of applications. Now, as I told you, there are hundreds, millions of species are there, and these are the most important: spirulina, synonymous. This is their lipid content, it is the oil and fat content, the maximum you can see. That is, this is the Batrococcus baroni, Nanochloropsis, and Neochloropsis. So many species are available, and their lipid content, it is 4 to 5 times higher than the vegetable oil and crops oil. It means you get a better yield, you get a better crops and better sun, you can say, absorption efficiencies. Now let's come to now another important area. That is a carbon dioxide mitigation is one of the best agents. I think from the scientific point of view, carbon dioxide can be mitigated if we properly use carbon dioxide, sunlight also, and the in India we have particularly, you can see the southern part of India, they have about 250 days of sunlight. And in the northern part of India, we have about 170 days of sunlight properly. You can sow in the morning time. And no, it is not only microalgae can be grown in the absence of light, which is called an autotrophic, or it is called a heterotrophic. You can use, but in that case, you need to use the source of carbon dioxide as an oil, sugars, oil, and other materials. That is okay. Now let's come to, nowadays the biggest problem is how to clean the dye effluents. Dye industry use a lot of dyes, green, blue, red dyes. And after the production of dye, they create a lot of effluents. And effluents contains all the toxic materials, toxic elements, toxics, even sometimes you can say the products which may not be required for our nature. And when such type of you can say effluents containing dyes goes to our rivers, they creates a lot of problems, kills all the fishes, animals, and others also. So how to decolorize this wastewater? The process is called biodegradation and industrial waste treatment. So microalgae has a lot of potential, you can say, in clearing, in the absorption of dye pigments from the effluents which is created during the manufacturing process of a different type of dyes used for variety of applications. Now, bioremediations of wastewater. In India, it is not much in demand, but if we go abroad, mostly in the USA and the European country, this type of industry, they use microalgae, piggery and tannery, leather industry, lot of effluents is produced. Effluents, treatment plants, you can say the wastewater from all the industry, metallurgical processes, dye cleaning, agriculture waste, lot of agriculture waste, and pharmaceutical effluents. For the growth of a microalgae, we need certain nutrients, nitrogen and phosphorus. And nitrogen and phosphorus, which is also, when we grow any crops, we add a fertilizer. What is fertilizer? Urea fertilizer, phosphate fertilizer. In a similar fashion, microalgae also needs nitrogen and phosphorus based fertilizer, which is called nitrate phosphates fertilizers, similar to the growth of crops and others. But these elements, nitrogen and phosphorus, they are the product of various industrial processes. So they come into the effluent, that is the waste water. Therefore, microalgae absorb these toxic elements from the water and clean the water like a fresh water. This water further can be used for our agriculture purposes. Now, toxic and hazardous elements are present in the wastewater, like arsenic, lead, mercury, molybdenum. These are hazardous, toxic, cancer producing. These are the, you can say, the elements which are not required, but due to the human activity, we throw them into the rivers without, you can say, putting them into any treatments. Now, how this wastewater process is carried out? This is an industry. Industry creates a lot of wastewater effluent. So we get a wastewater effluents here, and we add a microalgae culture. So many species are available. Again, I told you, chlorella, spirulina, and chloropis. They are the best agent to be used for the cleaning of water. So what you do here, you get a clean water, and this is a biomass. So it means lot of applications, lot of advantages. You get a biomass and the clean water. Clean water can be used for agriculture purposes, and maybe you can say even the generation nowadays in the generation of electricity for a smaller type of turbines. So this is the biomass. The biomass can be used because this cannot be used for, you can say, for food supplements, because it may contains a lot of toxic element, but it can be used as a fertilizer because this is rich in nitrogen, phosphorus, and minerals. You can convert it into bio oils, and bio oils can be used for biodiesels. Now, the biggest advantage to use microalgae for using the clean water for, you can say, for the effluent plant, it does not require any chemicals, which are normally used by the industry to treat the wastewater plants. So no hazardous chemical waste, eco-friendly and cost-economic process. You can say a lot of material you get also. So all your cost is recovered from the ATP plants. Now, this is my work, which could I able to carry out at Brazil and United States of America, University of Illinois. There, what we did, there were a lot of requirement how you can remove, you can clean wastewater, and most problem was the nitrates, because industry using nitrates for so many, from you can say as a, you can say, for the synthesis of so many products. So all industry were throwing effluents containing nitrates in the rivers, in the ponds, and others also. So we used this microalgae. We collected water, went to the industry surrounding Brazil and other parts of the America. We could able to collect waters, and we treated these microalgae. You just see in 15 days at the start, these nitro levels were very high. Just let us say it was about 160 milligrams per liter, but for the course of 15 days, we could able to reduce to a level of almost nil. So we tried experiment on wastewater, on fresh water, and other type water. So how this microalgae can remove nitrates, and in the water it was just like a clean. You can see in your face into the fresh water, like a fresh water only. Now, as I told you, how you can carry out the decolorations of the malachite green. This is one of the, you can say, most important dye which is used for so many applications, dyeing of clothes, dyeing of certain materials, plastic also. And industry creates a lot of effluents. Industrial wastewater contains a lot of this malachite green dye, and they all throw into the Yamuna in Delhi also, surrounding Delhi NCR, they throw into the Yamuna. So what you do, you can treat this water. This is a malachite dye. This is completely removed by the treatment of a microalgae. This is, you can see, this is a decoloration. This is a very, you can say, dark color material. You get it after removal. You get a very clean water. Now, as I told you, this microalgae biomass, it can be used for variety of purposes. Choice is yours. If you want a food materials, so you can use a certain type of microalgae species, so you can produce biodiesel and food. You can use a proteins. And if you want only food and proteins, which is only for the freshwater microalgae cultivation, which we call aquaculture, it contains all the essential fatty acids for human consumptions. And I told you, like a mother milk, or even food, infant for foods, food for infants, like that only, nutraceuticals and all that. And if you need only biodiesel, which is a B100, you can. So you can customize, depends upon you. It's all a scientific process. What do you need? So depending upon the choice, it is only the selection of the microalgae species and the optimization of cultivation media and light flux. You can create different type of products. Now, another question comes, which is my expertise. I'm an analytical scientist, rather I say analytical sciences. All these analytical instruments can be used for the structural characterization. All the Nobel Prize in the world, those who have gone a prize, they have used all the analytical techniques. Like these are the techniques: NMR, IR, nuclear magnetic resonance, maybe for the imaging also, transmission electron microscope, inductively coupled argon plasma, scanning electron microscope, X-ray fluorescence. These are the use for the structural characterization and quantitative analysis. This micromass, this is a biomass, is a black box. You do not know what is present in there. So you need these techniques for their characterizations. So it contains oil and fats, neutral lipids, glyceride, biofuels, PUFAs, so many things are. But how to characterize, you come to know, it's a lot of investigations, lot of interpretations, a lot of efforts are required. It is just, you can say, the complete post-mortem of the material, so that we can get a useful information regarding the types of the components present. 15,000 compounds are present. So these are one of the best techniques are used. Just like in the hospital, you carry out any test also, similar way, you can use the techniques for their characterization or the structure elucidations. One of the best techniques which is used is called nuclear magnetic resonance, which can easily distinguish the types of the oil. This is a soybean oil. It has all the characteristics. So this technique will tell you the types of fatty acid. What is the compost soy oil? Soy oil contains palmitic acid, 14%. This is stearic acid, around 4.4%. And this is oleic acid, linoleic acid, linolenic acid. Linolenic acid is called PUFA, which is good for our, I can say, a lot of, you can say, health benefits also. So these techniques can be used. Now let's come to our biodiesel. This is an algal oil. It has a different composition. This is called glycerides, TG. So you can use this technique as a quantitative for finding the so many parameters of the biodiesel. Biodiesel has to meet certain characteristics, certain standards, which have been specified by the American Standard of Testing Material. These are the specification of biodiesel. It has to meet certain specification before you can use it as a transport fuel. It has an iron value. It should have a polyunsaturated fatty acid. CETA number, the combustion characteristic should have 50. So this technique is very good for the characterization of the biodiesel produced from algal oil and biodiesel produced from any sources also. So you can calculate all different type of parameters. This is again, you can different type of algal oils. It is anyway. Let me skip this slide. Now let's come to, as I told you, the fatty acid compositions, or any, you can say, the composition of biomass. It depends on the microalgae species. We have a spirulina, tetrasalmis. These are the microalgae species and different type. They produce different types of materials. So this contains different type of oleic acid, linoleic acid, even PUFAs, that is DHA and DPA. So this technique is very good for the characterization, or you can say even you can monitor, you can control, you can do the monitoring for the selection of a certain species for the production of different chemicals. Now another technique is very good, which is this is electron spray ionization mass spectrometry. You are all aware of. Mass spectrometry is a technique which is, you can say, based on the ionizations of the atoms of the molecules also. So based on their ionization pattern, you can find out what is the type of the glycerides. These are all different type of glycerides, C14 fatty acid containing, you can characterize. And how you can convert into biodiesel also, it has a different profile. So this technique is very good, very useful even for, you can say, distinguishing or the characterization of the oil and fats and the biodiesels. As I told you in my previous slides, what is the composition of biodiesel? It contains all the fatty acids, and they are converted into methyl esters. So these are different type of you can say biodiesel. So biodiesel quality you can monitor with the help of this is a gas chromatography techniques. Gas chromatography technique. You can control the quality of the biodiesel. So I come to the conclusions. You know, besides the mitigations, you can say the minimizing the carbon dioxide in our Earth atmosphere, our Earth planet, it has a lot of other applications. Biodiesel, that I told you, food potentials, omega-3 fatty acids. These are PUF, I told you, omega-3 fatty acids. You can do the screening. You can do the kinetics of transesterification, phospholipids, carbon dioxide sequestrations, and biofertilizers, animal fodders, cosmeticals, and pharmaceuticals. So it means this is not the end. As I told you, a lot of research is going on. Nowadays, you can produce any molecules on in this world, medicine property. Even the fertilizers are nowadays being produced by the, you can say the utilization, you can say the capacity, and you can say the photosynthetic efficiency. You can produce any materials. That is. So, dear audience, whatever I have presented, it is my own work, which I am in a position to carry out in India, because basically I am a product of Indian oil corporations, where I spend a lot of my times. And then I in Brazil Institute of Meteorology, then University of Illinois. So this is all work has been, its original work presented. You can just type on the Google, that is Sarpal AS, you can find my publications also. So what you can do, even I invite you to collaborate with me in order to innovate and explore new possibility in the field of algae research, lot of potential. I think all my young students who are listening, they can even opt as a career. You can say it's a very innovative career. So thank you very much for your kind attentions. Nice of you.
I couldn't agree with you more, sir. Thank you so much. Thank you so much for your kind words. Aditi, over to you.
Sir, it was really amazing to know this new dimension and how we can utilize it for bolstering sustainability in the future. Now, I would open the floor for questions, and please kindly put the questions in the chat box.
So, Suchidi has asked one question. Ma'am, would you be opening more branches elsewhere? Alka, ma'am, this question is to you.
Oh, thank you so much. It is a very, very inspiring question for me, I should say. Now, one thing I did not mention in my discourse, and that is that at present, government of Assam have commissioned us to run 100 government schools in the lines that we are running Akshar Foundation. So we have just begun working with one government school, but the same thing: respect for ecology, recycling plastic, earning while learning, animal care of human beings. All these principles will be incorporated in the government schools. And before that, actually, we had adopted one school in South Delhi. South Delhi Municipal Corporation had given us one school. Um, School number 1, I forgot the name of the school, but it was in South Delhi. And we operated the school for about a year or so. But due to COVID, we had to shut it down. That school was very peculiar because most of the students came from orphanage, government orphanage, and others came from Basti. So that was a very difficult combination to work with. But even there, we realized that it is possible to operate the school with respect for ecology. So basically, uh, we are not thinking of opening more branches because that would, in a way, be an imperialism. Building up the empire, Akshar Empire. We don't want to build the Akshar Empire, but our idea is that if somebody wants to work on Akshar model, we are willing to share all the technology, all the teaching, learning material, and everything. Some of the apps we have developed, all this we can share if somebody is seriously thinking of doing something. And in India, several governments have requested us that in their own state, they want to start Akshar model. So far, we have very limited resources, manpower resources. So we are not doing that. But anybody who wants to do serious internship is welcome to Guwahati. This summer, students from Oxford University are coming to work as interns with the Akshar Forum. So any one of you wanting to do some internship in Guwahati, you're most welcome. And I'm sure we can continue to keep exchanging notes. Thank you.
Thank you so much, ma'am.
Akhilesh has asked, Sir, could you please elaborate on how the field of petroleum can pave the way for eco-entrepreneurship?
See, as I told you, a lot of potentials are there. Petroleum may not be used in future because of the environment, but some part will be used. So at the same time, you can have some entrepreneurship, better market in case of biofuels only. As I told you, microalgae is one of the concepts, but in future, the biofuels will be in great demand because it does not produce any, you can say, toxic gases, nitrogen, because it does not contain any nitrogen, sulfur, and other materials. So it is very clean fuel. And at the same time, the efficiency of conversion is very high if you compare it with the petroleum products also. So lot of potential. Even I told you, cooking oils. Cooking oil in the restaurant, what do? We throw away the cooking oil. Or other it is used for the production of soap even. But same cooking oil can be used into the biodiesel also. But the future is now the electric cars. Electric cars are there. So you people can even put up a lot of research how you can devise a battery. Why the cost of electric car is high? It is because of the battery even, because battery can last only say up to 500 kilometers, 600 meters. So lithium-based batteries are the lithium-based. But in future, you can devise another materials which will have equivalent, you can say higher, you can say the current ratio, which can produce a, you can say, better live battery. So these are the entrepreneurship. What I can say also, there's one Dr. Rupesh in the Chlorimal College. I've been good friend. I've been visiting in the past number of times, visited also. This micro algae you can start. You can start even cleaning the Yamuna. Yamuna you can start cleaning. What you doesn't need much. You need a culture, a biological student, a biology student who is, you can say, studying as a biochemistry. They can select any species chlorella which is present in the wastewater. Already you need not to produce. And some banks are available. You can start even cleaning. I visited one of your the physics department, even told me, can we clean our chemistry and physics lab effluents? Possible. Instead of throwing away, what you can do, you just take the effluent from the laboratories, clean with the algae, and you can have a fresh water, which can be used for other purposes also. So these are my certain ideas also. And a lot of ideas are there, we can discuss in futures.
Thank you, sir. Sir and ma'am, this question is to both of you. Rabinder has asked, can we do internship with you in online mode?
To me question or to Professor Alka?
Sir, this question is to both of you.
Okay, let Alka, Professor Alka should reply.
Okay.
Then I'll come to you.
Yes, thank you, sir. Thank you, sir. Ladies first. That is what you are following.
Okay.
See, internship online internship is possible, but one doesn't learn anything as such, isn't it? How to interact with the students, how to build up rapport, how to address the issues. These are the important things. If you want to do online internship, then it would mean that you look for some material for us, like Dipor bill. I was listening to presentation of Sarpal sir with a lot of interest, because the wetland near which our school is situated, Dipor bill, that is getting polluted because of the waste dumped into it. And the Guwahati Municipal Corporation is dumping its waste near the depot bill. So the stink is coming. So with sir's method of using LAG, maybe we can clean up that space. So if you want to do internship with both of us, maybe you can learn how he does it and apply it in Guwahati. That will serve both the purpose. Whatever the expertise that he has developed, that can be applied in Guwahati. I think that's possible.
See, as I told you, Delhi University is not new to me. Professor Sharma, Professor Rupesh, even so many I'm aware of, because I've been brought up in Indian Oil Corporation, Faridabad. I'm a resident of Faridabad. Presently, I'm in Panipat because I'm working for some petrochemical company. But I will be relieved this month. Most welcome. You can call me, not online, as Professor Alka told you, may not be benefit. You can call me in your institute, Delhi University, or your on Bhumi, you can say platform. So I'll be ready there to guide you. Not only on microalgae, I can be as a teacher. I can teach you a lot of passion. I've been doing in the past also abroad and in India also. So any topics of, as I told you, all the Nobel Prize winners, they could not have won the Nobel Prize if they have not utilized the analytical technique. Have you heard of this microimaging? In the hospitals, NMR imaging, you can find out the cancerous cell in your body. That is our specialization. This is one of the techniques. So you can call me. I will be freely available. It is my pleasure to guide you on all topics of science, not only chemistry. That is what I can say. Okay.
Thank you, sir.
I shift into Faridabad. There in my residence, so Delhi is not far away from me.
Yes, sir. Thank you, sir.
Thank you so much, sir and ma'am. So this question is again from Ravinder. And this question is particularly to ma'am, and he asks that how do you get this idea of starting the Akshar Foundation?
I will try to be very brief, okay? Because I have been a teacher all my life, and you know what happens to a teacher when there is a mic and when there are eager listeners. One has a tendency to go on and on. So first of all, see, there is an intergenerational cycle of poverty. A family is poor because it is poor. Because a poor family means the children will go to a bad school, they will drop out early, they will not learn anything, they will have low self-esteem, they will marry early, they will produce children early, and those children also will go through the same cycle. They will start working early, and the father or the parents, they will also die early because longevity is very small, very, very less. So if one wants to break the intergenerational cycle of poverty, what can be done? Good education is the only solution. Secondly, the problems that we are facing the world over, all these can be said, can be characterized as failure of education system. We say educated, unemployed. See, it's a misnomer. A person who is educated cannot be unemployed, because what is the meaning of education if a person cannot look after oneself? Isn't it? So the question here is that because of lack of good education, and because of lack of good education accessible to all sections of society, we see so many problems, and the problem of artificial intelligence taking over, the problem of ecology being destroyed. We require quick solution. And quick solutions will come only if our young generation, you guys and the next generation, is properly educated, and innovative solutions can come, and wasteful practices will stop, and the intergenerational cycle of poverty can be completely eliminated, and each and every person in this world will have right to live with dignity and the wherewithal to live with dignity. These were the thoughts in our minds. So we started on providing good quality education which is equally accessible to all. Thank you.
Thank you, ma'am. So we have our next question. Again, Suchiti has asked. She has asked, I read somewhere that COVID waste like PPE kit and masks are creating a lot of problem. Can that be used to make bricks as well?
Should I answer?
Yes, sir. Yes, sir. Sure.
You see, you are talking about, yes. I heard in the this northeast part of India, somebody has prepared a building based on plastic bottles. He raised a wall even, except the roof also. Yes, it is possible. Actually, this mask material, it is a polypropylene. It's one of the layers is polypropylene, which is a petrochemical product. It's a petroleum products also. What you can do also, and not only this all even bottles even that you can even regenerate, do the regenerations also, and you can prepare the boxes also. But again, what will be the problem? These plastic material degrade in sunlight. It will create a lot of problem for you. The best solution is let us avoid plastic. Use jute batches also, which petroleum companies are not advertising. Why? They will lose business. They will lose business, but nowadays you can say there's a combination of jute and petrol. I have a lot of petrochemical, you can say, experience. These materials, even every materials, whether it's a solid, a liquid, or a metal, they have a biodegradability. I just give an examples. Aluminium has 200 years. It can be there 200 years. Plastic can be even up to 100 years also. What is jute? Jute you can degrade in 2 years even all that is also. So why to use all? Yes, it can be prepared, but what will be if impact on environment? Better, whatever the material it is created, it is waste also. You dump it. That is a better way in the earth, not into the rivers and also. So let us please say no to the plastic. That is my motto. I always say let us say no to the plastic. Don't use plastic. Let us use other material. What is everything in our house? All our utensils, all our chairs, even it used to be wooden also. So let us please. This is my just an idea I have shared.
Ma'am, do you have anything to add on to what sir has just mentioned?
How can I have anything to add? He is an expert in the field.
सी
Yes.
वाई प्लास्टिक मैं आप मिनिमाइज करिए प्लीज आप थोड़ा इसको मिनिमाइज करिए यूज करना प्लास्टिक को
Exactly.
at least some percentage you can reduce it. What is the source of, you can say, the raw material is petroleum. We crack the petroleum, produce ethylene propylene gas and convert it into the, you can say, plastic.
Correct.
So let's
There's
avoid
question.
एक सुनिए, मैं हिंदी में तो बोलता हूँ, एक ग्लास को आप कितना यूज कर पाएंगे? एक ग्लास 50 साल तक नहीं जाएगा स्टील का. एक प्लास्टिक का ग्लास कितना चलता आपका? 1 year, 2 years, it degrade also. So how much you can say you are spoiling the environment. We are responsible. Everybody is responsible. Not any government. All human, we are responsible for that.
I can
Absolutely,
see a
sir.
question from Nitin Kadian regarding
Ma'am, I can read the question for you. So Nitin has asked, how did you get the land for the Akshar school? Was it given by the government, or only what should we do if we have the idea but no capital or land?
Very good question again. See, before we started Akshar School in Pamohi, we had started work in different parts of Guwahati in association with different clubs. And like Harijan Colony, we started work then in association with different clubs. But everywhere, after a few months, when the organizers realized that there are too many skeletons in the cupboards and that we have come to know about the skeletons, they would sort of make us go. So then we realized that we have our family had some land. It was basically an agricultural land, small plot of land, far away from Guwahati, in a suburb, in a remote village near Guwahati. So then we shifted to that place and we started working over there because it's predominantly tribal land. So at present, our school is situated in our own family land. That problem, government has not given us land, and governments don't normally help such initiatives to begin with. When you have reached a certain level, maybe the government can support something. So capital also, we used all less capital intensive methods to sort of run the school. As you have seen that the building material was locally available, the laborers were also locally available and all that. But CSR provides an interesting and a reasonably good source of funds, because all companies have CSR funds. And if you do some small little thing in a meaningful way, take 100 students, or maybe less than 100, maybe 30, 40 students in your own location, write the project proposal properly, and then you will be, and once you have a society, of course, a registered society or a trust, so after 3 years, you will be entitled to get CSR funds. If you go through the Akshar website, www.aksharfoundation.org, there you will find a lot of interesting news and videos, and also the people who have started supporting us now. You will get all the details over there.
Thank you so much, ma'am, for addressing the questions. I personally have a question for both of you. So I really wanted to know that, can we say that exposing the underprivileged sections of the society to eco-entrepreneurship can pave way for them for self-sustenance? Can we say that? And if yes, then how is that possible? How are you going to substantiate this argument?
मैडम जी बोलिए, आप पहले बोलिए प्लीज. आपकी आवाज नहीं आ रही है.
Ma'am, you are on mute.
Okay. Yes. Aditi, your question is that how do we draw the weaker sections of the society to ecological entrepreneurship, isn't it? To improve the way of life. That is your question.
Ma'am, my question is that, can we say that exposing the underprivileged sections of the society to the concept of eco-entrepreneurship can pave way for them for self-sustenance? Can we say that?
Yes, definitely we can say that. However, the eco-entrepreneurship as a subject as a field, it is new field in a way. And for an underprivileged person to be able to access right kind of advice and right kind of framework to go ahead, people like us have to help. And Professor Mr. A.S. Pal sir had also mentioned in the course of his lecture that he is willing to help. So one of you can choose an area from Delhi where the waste you want to convert into some product, or clean some parts of river or some rivulets. You can take up some project like this. Sir, if sir helps, and if CSR fund comes from some institution, you will definitely be able to involve weaker sections in their own betterment by making them eco-entrepreneurs. I think part of the question I have answered, and the rest I think sir will answer.
See, I 100% agree with Professor Alka. The downtrodden peoples, or who are the below poverty line also, even they are not aware of what is eco, how they are concerned. If we are in a position to guide them, to make them aware, how can be they part of the society to clean the environment also? You know how much water we consume in the urban area? I think maybe the 10 times as you can see in the rural areas also. So they can be a part of also. As I told you, I give you a very small example also. Jute. You know, from the jute evens, we can make a petrol also. But because it is all starchy materials also, so many you can convert it in also. So these people, if you can make a part, you can make to understand the waste is also very useful. The only question is how to manage the waste. Tell them also this waste can be used for the plastic bottles also. They are throwing outside also. The world over, it is a very worse situation. All the, you can say, the parts of, you can say in the sea levels even, see, you can say there's certain area they have consumed for, you can just, for, you can say the as a the filling materials also. Is it advisable nowadays also? So if we spread this message also, please don't waste your waste. This can be used for so many purposes. We are throwing plastic bottles. We are throwing plastics also. We are making, instead of buying wooden material, also we're going for the plastic. I know plastic material is cheaper than the wooden materials also. But why not? I give an example. One glass of steel can longer for a 10 years compared to one glass of a plastic also. Similarly, so many examples are there also. So I'm sure Professor Alka is doing a good job also. They can, because I was not in certain areas also, but definitely we can help. We can educate them also. I can give a free lectures also, free teaching also. What is the importance of our ecosystem also? So everybody can be a part of it to make it more cleaner, more, carbon dioxide level when rise also, what will happen? We are thinking about another 50 years. Why not to bring that situations also? Work. And see the example also. No, who are the people responsible for, you can say, the more carbon dioxide emission? When you use your computer for half an hour also, you generate about 250 grams of carbon dioxide. How? Why? Because when the computer parts burn also, electronic part, it creates a carbon dioxide. It takes oxygen and convert into carbon dioxide also. All this, you can say, all the biggest, the Sony is the biggest culprit. Today I read an article, because it creates a music system also for our world, also for our use, for the students. So many games, he game, auto games also. एक कौन से आजकल जो बच्चे गेम खेलते हैं, क्या मैं भूल गया उसका नाम, मेरा मेरा बेटा भी खेलता है. So how much carbon dioxide is produced? He says when you develop one games, at least 800 kilograms of carbon dioxide is produced by the development of a one games. And how many people are using also? Why not to make aware these people also, our students also? Please don't use a computer much also. Only use it when it is required for your education purposes also. So these are the, you can say, students, even even you can say our parents, our public needs to be educated about, you can say, the health, deterioration, health effects of the use of the computer. And at same time, I think some restriction should be there on, you can say, the developers like Sony and other music system also. They created such games also which should no longer last, so that at least you can save the system by not producing carbon dioxide. This is just my views.
Thank you so much, sir and ma'am, for addressing my question. And keeping children away from mobile phones and games is definitely a Herculean task, but we'll try our best. So, coming to the end of this Q&A session, that was an interactive session. Now, I would like to call the president, Aditi, to give a vote of thanks and e-mementos to our convener and guest speakers, and appreciate them for what they have helped us in knowing today.
Thank you so much, Aditi. Thank you, sir, Pal sir. Thank you, Alka ma'am. It has been seriously very insightful. हम लोग देखते रहते हैं ये चीजें, हम पढ़ते हैं इनके ऊपर, बट काम इस पे बहुत बार हो पाता है कि हम इम्प्लीमेंट कैसे करें, क्योंकि कई बार ऑल्टरनेटिव्स नहीं होते, और अगर ऑल्टरनेटिव्स होते तो हम कॉन्शियसली उसके ऊपर वर्क नहीं करते. तो जैसे आपने गेमिंग बताया, जैसे आपने बताया कि प्लास्टिक को हम कैसे रीयूज कर सकते हैं, दीज आर वेरी छोटा छोटा चीजें जो करने से बहुत चेंज आ सकते हैं. So if every one of us does this, and I'm sure most of the Bhumi sapiens would be, inspired to do this, तो हम बिल्कुल अपने level पे ये try करेंगे. Thanks to our speakers for enlightening us on the topic of eco-entrepreneurship. We are grateful for a patient audience who made this session a success. We will be launching our annual e-magazine on our Instagram accounts and also in the WhatsApp group. So please stay tuned in. I would also request everyone to switch on their camera so that we can take a picture. Whoever is clicking the picture, let us know once they're through with it. Thank you so much. Now request Swati to present our annual magazine, so all of you can have a look at it once.
Yes, yes.
हाँ स्वाति.
Very good. It's nice.
Thank you so much, sir. Thank you, Swati. Swati, could you please present the mementos?
Aditi, I have one question. Can I? Hello.
Yes, sir.
Aditi, can I send an articles to your magazine?
Yes.
Sir, you can totally send it to us. We'll edit it in.
Sure, sure. On topics, I'll send it to you. Thank
Yes,
you.
sir. Thank you so much, sir.
Sir, it would be a privilege to have your article in our magazine.
Sure, sure. I'll send you definitely. That's
Alka ma'am, kindly accept this e-memento as a token of gratitude from Team Bhumi. Sir, please accept this e-memento as a token of gratitude.
my honor and grateful to you for giving this memento. I will remember forever.
Thank you so much. Aditi, you can go ahead.
It was phenomenal to have our e-magazine launched in the presence of such erudite luminaries, and we are really grateful that you took out your precious time and gave your important time to us and for enlightening us about so many new things that we had no idea about. Thank you so much, sir, and thank you so much, ma'am. And special thanks to our audience for being all ears and for listening to each and everything so meticulously. Thank you so much. And it's a delightful experience. Thank you.
Thank you for hearing us patiently and asking very interesting question. It was an enlightening lecture for me too.
Thank you so much for giving us opportunity. It's a really wonderful, Eco Club is a wonderful and nice opportunity to meet Professor Alka and his work for the social organizations and the downtrodden peoples. Thank you, Professor Alka, and all the organizing committee members.
Thank you, everyone.
Thank
Now
you so much.
everyone can leave the meeting. Thank you, everyone.